Hello everyone. This is Ms. Pooja Patle, Assistant Professor Tulsiramji Gaikwad Patil, College of Engineering, Nagpur. In today's session, we'll see about the control flow testing in software testing and quality assurance subject. So, let's see what does mean by control flow testing and how it works. First, we'll see the introduction of control flow testing. So, control flow testing is a structural testing strategy that uses the program's control flow as a model. It is a testing technique that comes under white box testing. The entire structure, design, and code of the software have to be studied for this type of testing. So, for control flow testing, the one should know about the entire structure, design, and code of the software. Often, the testing method is used by developers themselves to test their own code and design as they are very familiar with the code. This method is implemented with the intention to test logic of the code so that the required results or functionalities can be achieved. Its applicability is most to relatively small programs or segments of larger programs. Thus, it is mostly used for unit testing. So, control flow testing basically tests the code of the software. Outline of the control flow testing. As you can see here, the path selection criteria and the program unit as an input. Here, in path selection criteria, we go through the program unit, then draw a control flow graph, that is CFG. Control flow graph we get, and then we select the path which is feasible or not. We have to check it is feasible or not. So path selection criteria, by using that we'll select the path. Then the selected paths will generate the test input data, and then it will check are the selected paths are feasible or not. If yes, then the test input data will get as an output. So this is the process of generating test input data. Process of control flow testing. So see, in control flow testing, there are two kinds of basic statements in a program unit. Right? In a program unit, there are two kinds of basic statements. And what are they? They are assignment statements and conditional statements. So, an assignment statement is explicitly represented by using an assignment symbol that is equals to, such as x is equals to 2 into y. This is assignment statement, where x and y are variables, and the symbol we are using for multiplication is nothing but the operator, right? And we are assigning that values by using equals to sign, right? So this is the assignment statement. And the another one is program conditions are at the core of conditional statements, such as by using loops, by using if, for, loop, while loop, we give the conditions, right? So These are the conditional statements. So now we'll see the process of control flow testing. So the basic idea behind control flow testing is to select paths and come up with the inputs. That is, in inputs, it may be the input values or the test cases. To execute through those paths, it includes the following 4 steps. Now, what are these steps? Step number 1. From the source code, a control flow graph, that is CFG, is created either manually or automatically using a software. Automatically, we are using the automated tools for testing. So, the first step is from the source code, a control flow graph is created either manually or automatically. Step number 2. A coverage target is defined over the CFG, that is nodes, paths, branches, edges, etc. Step number 3. Test cases are created using CFG to cover the coverage target. In coverage target, it may be statement coverage, path coverage, branch coverage, predicate coverage. So test cases are created using CFG to cover the coverage target. Step number 4. Execute the test cases. And step number 5. In step number 5, we analyze the results and determine whether the program is error-free or has some bugs. So this is the process of control flow testing. Now control flow graph. The control flow graph is a graphical representation of control structure of a program. Following notations are used for a flow graph. The first one is node. Edges or links, decision node, junction node, reason. So these are the notations used in the graph. So node represents one or more procedural statements. What it does? It represents one or more procedural statements. Edges or links. They represent the flow of control in a graph, in a program. Decision node. A node with more than one arrow leaving is called a decision node. Junction node. A node with more than one arrow entering it is called a junction. And the reasons are nothing but the areas bounded by edges and nodes are called regions. So in control flow graph, these are the notations which are used for flow the graph. Now here the cyclomatic complexity. How it measures? What is that? So cyclomatic complexity measures the number of independent paths through a program source code. Cyclomatic complexity is computed using CFG. The formula used for calculating cyclomatic complexity is M is equals to E minus N plus 2P, where E is equals to edges, N is equals to nodes, P is equals to components. Or M is equals to D plus 1, whereas D is equals to decision node. Or the another formula for that is M is equals to R plus 1, where R is enclosed region. So these are the some formulas using which we calculate the cyclomatic complexity, as you can see over here. So now the paths. What are the paths? A path through a program is a sequence of statements that starts at an entry, junction, or decision and ends at another possible the same junction, decision, or exit. So, the path is nothing but the flow of the program from start to end, from entry point to exit point. A feasible path in CFG is one which can be verified by a set of possible inputs. Infeasible path is such a path in CFG that cannot be verified by any set of possible input values and most expensive activities of software testing. An independent path is any path through the graph that introduces at least one new set of processing statements or new condition. So this is all about path. Path is just a flow of the program from entry point to the exit point. These are the sequence of the statements that starts at an entry, junction or decision and ends at the same points like junction, decision or exit point. Path selection criteria. In path selection criteria, the statement coverage, decision coverage, and conditional coverage are there. So, statement coverage is assumed that if all the statements of the module are executed once, every bug will be notified. In decision coverage, this criteria states that one must write enough test cases such that each decision has a true and false outcome at least once. In condition coverage, in this case, one writes enough test cases such that each condition in a decision takes on all possible outcomes at least once. So this is the path selection criteria, that is statement coverage, decision coverage and condition coverage. Now the advantages. What are the advantages of control flow testing? So it catches 50% of all the bugs caught during unit testing. What it does? It catches 50% of all the bugs caught during unit testing. That amounts to 33% of all the bugs caught in the program. Experienced programmers can bypass drawing flowcharts by doing path selection on source code. The flowchart can even be made by an automated program software and is not necessarily drawn by hand. So these are some advantages of control flow testing, and here these are some disadvantages listed. We are unlikely to find spurious features that were included in the software but were not in the requirements. It's unlikely to find missing paths and features if the program and the model on which the tests are based are done by the same person. Coincidental correctness, however, improbably defeats this technique unless we can verify all intermediate calculation and predicate values. So these are the advantages and disadvantages of the control flow testing. So yeah, thank you.